The Velnari Collective had been in charge of the stars for more than 3,000 years. The quantum communications array was the best thing about galactic civilization. It was a huge network of relay stations and quantum processors that connected 847 star systems across the galaxy. This network sent every trade agreement, every diplomatic message, and every emergency call for help. Without it, the galaxy would break up into small pockets of civilization that couldn't talk to each other, like islands in an endless ocean. Then all of a sudden, everything started to fall apart. It started out small. A mining colony on the edge of the galaxy said they were getting mixed-up messages. The commander of the station thought it was just a problem with the local network, so he ran standard tests. Everything looked good. 2 days later, a diplomatic message between the Velnari High Council and the Azurite Federation came in all messed up. What should have been a calm trade talk sounded like random noise. Then a distress call from a cargo ship went missing completely and never made it to the nearest rescue station. The ship and its 40 crew members were lost. The failures spread through the network like a disease within a week. Messages that should have taken microseconds to send were taking hours, arriving broken beyond recognition, or not showing up at all. The rate of failure went from 1% to 5%, then to 10% and finally to 15%. The galactic community was in a state of panic. The stock markets fell. Trade routes were closed. Families couldn't get in touch with loved ones who were serving in far-off systems. Chief Engineer Talvos stood in the main control room of Hub Station Prime, watching the main screen with growing dread. He was a Velnari, a tall reptilian creature with 4 strong arms and scales that changed color from green to blue depending on how stressed he was. They were almost all blue at the moment. There were red warning signs all over the huge holographic display, each one showing a different failed communication node. His team of technicians worked quickly at their stations, running diagnostic tests one after the other. Status report, Talvos said, his voice full of authority because he had been in charge of this network for 40 years. Seltris, a younger Velnari who was his second in command, used all 4 of her hands to control her console. Failure rate is now 23% and going up. We can't get in touch with 7 systems in the outer reach anymore. The quantum entanglement matrices are showing normal numbers. The flow of energy from the neutron star is steady. I don't get what's going on. Talvos felt his blood turn cold. 23%, almost a quarter of all communications in the galaxy were not working. He had never seen anything like this in the 40 years he had worked there. It took hundreds of years of work to perfect the technology used to build the array. It had backup systems for its backup systems, fail-safes that were supposed to be foolproof, and redundancy systems. The neutron star that powered the whole network was stable and was always watched by the best astrophysicists in the galaxy. Do a full system check on Sector 7, he told them, and get me readings from the relay stations close to the core. The group worked all night. All of the tests came back normal. The quantum processors were working perfectly. The states of entanglement were stable. The distribution of energy was just right. But the failures kept happening like cracks in a dam that was about to break. The Galactic Council called a state of emergency at the end of the first month. The Velnari, who are usually proud and self-sufficient, did something they don't often do. They asked for help. Ships from all over the galaxy brought the smartest people from a dozen different species within days. The crystalline Azurites sent their best quantum physicists, who were living crystals that could do calculations faster than supercomputers. The Kelsorii hive mind sent their mathematician priests, who thought as one and could solve problems that would take individual minds hundreds of years to figure out. The mysterious Phazine sent their reality engineers, who were able to see and change dimensions that most species couldn't even see. Hub Station Prime turned into a circus of alien brains. All the workspaces were full of different species, each with their own strange tools and ways of doing things that made no sense. The Azurites built crystalline resonance chambers to study quantum fluctuations at levels smaller than atoms. The Kelsorii made huge mental calculation matrices, with their 100 linked minds working together as one big processor. The Phazine put in dimensional scanners that hurt to look at. These devices seemed to be able to move in more directions than 3-dimensional space should allow. Months went by. The galactic credits came out like water. 47 million and counting. Every week brought new ideas, new tests, and new failures. Each team thought they were about to make a big discovery, but then they ran into another dead end. The failure rate went up to 25%, then 28%. Now, whole parts of the galaxy were working almost completely alone. The economies fell apart. Governments fell apart. The social fabric that had held the galactic collective together for thousands of years was falling apart. Talvos hardly slept at all anymore. For weeks, his scales had stayed blue. He read reports until his eyes hurt, went to briefings with experts who spoke in math terms that made his head spin, and watched helplessly as the network he had worked so hard to keep alive slowly died. The worst part was that every test, scan, and analysis said the same thing that couldn't be true. The array should work perfectly. The 6th month of the crisis came and there were still no solutions in sight. Talvos stood on the observation deck of Hub Station Prime, looking out at the neutron star that powered the whole communications array. The star spun quickly, and its surface crackled with energy that was collected and turned into the power needed to keep quantum entanglement going across hundreds of light years. It looked the same as always, beautiful and scary, like a cosmic engine that had never let them down before. There was a lot of frantic activity going on behind him at the station. So far, 47 million galactic credits had been spent, and that number grew every day. The amount was so huge that it could build 3 new colony worlds or pay for 100 research stations for 100 years. And they didn't get anything out of it. The Azurite quantum physicists had been working non-stop for months. These crystalline creatures didn't sleep like living things do. They just went into rest states, where part of their mind kept working on data while the rest of it recharged. Their head scientist, whose name roughly meant harmony of calculated waves, had set up tools that could measure quantum fluctuations at the Planck scale, which is the smallest measurement possible in physics. They looked at every quantum processor, every relay station, and every entanglement node. Their readings were perfect. There wasn't a single quantum state that was out of line. Every particle acted as it should have. It doesn't make sense, Harmony had told Talvos at their last meeting, their crystal bodies bending light into rainbow patterns as they talked. We have measured every possible quantum interaction. The entanglement is stable. The rates of decoherence are within acceptable limits. Based on everything we know about quantum mechanics, this system should work perfectly. But it didn't. The failure rate was now at 29% and still going up. The Kelsorii mathematician priests took up an entire wing of the station. The Kelsorii were different from the Azurites in that they were a hive mind species, with hundreds of bodies all connected to one mind. They didn't work together when they were trying to solve a problem. They just thought as one big brain. They had made mathematical models of the whole communications array, with simulations so detailed that they included every particle, every change in energy, and every possible variable. They did billions of virtual tests to look at every possible way that things could go wrong. 3 weeks ago, their prime mind gave the council its results. Talvos remembered sitting through the 4-hour presentation, watching as equation after equation filled the holographic displays, each one more complex than the last. Only a few people in the room could even understand the math because it was so advanced. The end was easy and annoying. The prime mind said, "No mathematical model we have built can reproduce the failures we have seen." Its 100 bodies spoke in perfect unison. "We have tried out every known variable. We have added patterns of random errors. We have simulated equipment failure, changes in energy, and quantum noise at levels that are much higher than what we have seen. The array works fine in every simulation. We can't make our models fail like the real system is failing." This meant that either their math was wrong, which seemed impossible given the Kelsorii's reputation, or something was happening that their models didn't take into account. But what? They had put in everything they could think of. The Physine reality engineers were probably the most unusual of all the experts. These beings lived in part outside of normal three-dimensional space. Most species got headaches just from looking at them. They had brought devices that could scan dimensions that most beings couldn't see, looking for strange things that might be messing up quantum communications. They looked for unstable dimensions, strange particle interactions, and even ripples in spacetime itself. Talvos had seen them work even though it hurt his eyes to do so. The lead engineer moved around the station in ways that didn't make sense from a geometric point of view, taking paths through space that shouldn't be there. The frequencies of their equipment made reality itself seem to vibrate. They had found nothing strange after 2 months of very careful scanning. There are no dimensional rifts, no strange particles, and no strange things happening in spacetime. The fabric of reality in this area is perfect, the Physine leader said, and their voice seemed to come from more than one place at once. "We haven't found any problems that could explain why communication isn't working." Every day there were new consultants, new ideas, and new dead ends. A group of Draxian engineers, known for making megastructures that could survive inside black holes, looked at the relay station's physical parts. They didn't find any signs of wear and tear, structural damage, or material fatigue. A team of Meridian energy experts looked into the power distribution network. Every conduit, every converter, and every storage cell worked perfectly. The neutron star's output stayed the same. The daily briefings turned into frustrating exercises. Talvos would sit at the head of the conference table, surrounded by the smartest people in the galaxy, and listen as each team told him the same thing. Everything was fine. Everything is working normally. No problems found. But the failure rate kept going up and up. The political pressure was too much to handle. The Galactic Council wanted updates every day. Planetary governors called all the time to ask when their systems would be able to talk to each other again. Trade guilds said they would sue. Defense fleets said they couldn't work together well because they didn't have reliable ways to talk to each other. 3 different governments had already fallen apart because they couldn't keep in touch with areas that were far away. Seltris walked up to Talvos on the observation deck, and her scales had some blue stress color on them. "Chief, we just got another report. The rate of failure reached 31%. We can no longer get in touch with 14 systems. The Council wants answers." Talvos briefly closed all 4 of his eyes. 31%. Almost a third of all communications in the galaxy were not working. And they still didn't know why, just like they hadn't 6 months ago. Spent 47 million credits. The best minds in the galaxy work all the time. A lot of data was looked at. Hundreds of tests were done. Nothing at all. "What should we say to them?" Seltris asked in a low voice. Talvos opened his eyes and looked at the person who was second in command. "The truth. We don't know what's wrong." The words tasted like losing. The Galactic Council's emergency meeting was very tense. Hundreds of people from different worlds filled the huge room, and their voices echoed off the curved walls as they argued, blamed each other, and asked for answers that no one had. Talvos stood on the middle platform, feeling the weight of their stares. He had just finished saying that they still didn't know the answer after 6 months of work and 47 million credits. The room was full of chaos. A delegate from the mining world said that the Velnari were not capable. A representative from a trade group said they would impose economic sanctions. Someone from the outer colonies yelled that whole settlements were being left behind because families couldn't get everyone out without good communication. Vrenta, the council speaker, who is very old and comes from one of the oldest civilizations in the galaxy, raised her hand to ask for silence. The room slowly got quieter. She looked small and weak, but her voice had the authority that came from 200 years of service. "We have used up all of our normal options," she said slowly, her words carefully chosen. "Maybe it's time to think about new ways of doing things." There was a wave of confusion in the chamber. What could be more out of the ordinary than hiring reality engineers who could see into other dimensions? A young delegate named Kresh, who was one of the junior council members, spoke up. "Speaker, if I may. We haven't looked into one option yet." Vrenta told him to keep going. "Earth?" Kresh said. "The people." For a moment the room was quiet and then everyone burst out laughing. Not mean laughter, but the kind of laughing that happens when you hear something silly. People? The species that had just begun to make reliable fusion drives? The people who were still using simple computers that could fit in one room? The people who had only been in touch with the larger galactic community 20 years ago? Someone yelled, "This isn't the time for jokes." But Kresh kept going and his voice got louder. "I'm not kidding. For 2 years I worked as a liaison officer on Earth. I learned about their past and how they worked. People are known for finding unexpected ways to solve problems. They deal with problems in a different way than we do." Another delegate said, "Because they're primitives," in a dismissive tone. "They don't really get quantum mechanics. What could they possibly add that the Azurites or Kelsorii haven't already done?" Kresh brought up a holographic display. 3 years ago, a group of people who were mining on Outpost Kepler 442 got stuck there when their life support system broke down. The system was designed by Velnari and was cutting edge. The automated diagnostics weren't able to find the problem. There were 2 days of air left for the crew. They sent out a distress signal, but the closest rescue ship was 4 days away. As the delegates leaned in, the room got quieter. Travis Bowen, a human engineer, didn't pay any attention to the diagnostic computer. He took the system apart with simple hand tools, piece by piece. He discovered that a valve had been put in the wrong way during the last maintenance check. A simple mistake that the high-tech sensors didn't catch because they were only looking for complicated problems. The system worked perfectly after he turned the valve around. The crew made it. Vrenta thought about it and narrowed her eyes. One event does not make a pattern. Kresh went on to say, there are dozens of similar events on record. When the Meridian Colony's water purification system broke down, their best engineers spent weeks running tests. A human technician fixed it in 6 hours by replacing a worn gasket that the sensors couldn't find because it was still within acceptable tolerances. For months, Draxian electricians couldn't figure out what was wrong with the trading station at Proxima because the power kept going up and down. A human electrical worker found a loose connection in a junction box that no one had physically checked. Talvos felt something move in his chest. Not quite hope, but maybe the faintest hint of it. Are you saying that people are good at solving simple problems? Kresh said, I'm saying people still know how to look for simple problems. Most of our civilizations have been advanced for so long that we've forgotten how to fix things. We make complex diagnostic systems and have complete faith in them. People can't do that. Because their technology breaks down all the time, they have a culture of solving problems by doing things themselves. They check the obvious things first because they can't afford not to. There were whispers in the chamber. Some of the delegates looked interested. Some people still weren't sure. Their technology is hundreds of years behind ours, Harmony, an Azurite physicist, said. How could simple tools find things that our quantum scanners can't? Maybe that's the point, Vrenta said in a low voice. We've been using the most advanced tools in the galaxy to look for advanced problems. Maybe we need easier tools to solve easier problems. The argument went on for another hour, but in the end, desperation won. They had tried everything else. What did they have to lose? The council voted by a small margin to send a request to Earth. Not a job offer, just an invitation. One engineer who is a person and is there as a consultant. At the very least, it might give you a new way of looking at things. That same day, the message was sent to the Planetary Council on Earth. It told them what was going on and asked if they knew anyone with experience in communications engineering who could help. The tone was careful and diplomatic. It wasn't quite condescending, but it also wasn't expecting much. The message caused a lot of trouble on Earth. Most engineers would have never thought they would get to work on alien technology. Thousands of applications came in. It was hard for the selection committee to pick just one person. They chose Jake Morrison, a 34-year-old communications engineer from Denver who worked on the Deep Space Monitoring Network for Earth. His history showed a pattern that was similar to what Kresh had said. He was good at figuring out problems that were too hard for his more academically successful coworkers to solve. His reviews always talked about how he was hands-on and how he always checked equipment in person instead of just using computer diagnostics. Jake got the message while he was fixing a broken relay in the main antenna array at Station 7. His boss called him down from the tower and he looked shocked. She showed him the message on her tablet and said, "You won't believe this." Jake read it twice, sure it was a joke of some kind. Did the Galactic Council want him to fix a communications array that even the best experts in the galaxy couldn't? Is this real? He asked. Very real. Tomorrow a ship will come to get you. This is big, Jake. You would be speaking for all of humanity. Jake looked down at his dirty work clothes and the simple tools that were hanging from his belt. He would be on a starship tomorrow, going to the center of the galaxy to fix a problem that had stumped alien geniuses for 6 months. He laughed in a nervous way. Not a lot of pressure, right? 3 days later, Jake got off the transport shuttle at Hub Station Prime. He had a regular Earth toolkit, a diagnostic tablet that looked like a toy next to the alien technology around him, and a thermos of coffee because the briefing packet said the station's replicators couldn't quite get the taste right. He had no idea what he was doing when he got there. Jake was blown away by Hub Station Prime the first time he saw it. The station was huge, at least 10 times bigger than anything humans had ever built in space. The hallways went in impossible directions, bending up and around in ways that made it impossible for him to know where he was going. Some of the aliens he had only seen in training videos walked by him. Some walked on 2 legs, some on 4, and some floated in containment fields. The recyclers couldn't quite get rid of the strange metallic taste in the air. Talvos saw him in the main docking bay. The chief engineer of the Velnari was at least 2 feet taller than Jake. He had 4 arms that moved in ways that Jake's cultural briefing had taught him meant, hello. His scales were mostly blue, which seemed to mean he was stressed. Talvos said, Engineer Morrison, in perfect English, but his translator made the words sound a little mechanical. Hello and welcome to Hub Station Prime. I hope your trip was pleasant. Call me Jake, he said as he shook one of Talvos's hands. The scales felt cool and smooth like touching smooth stone. And yes, the trip was great. First time traveling faster than light. Pretty amazing. Talvos showed him around the station's hallways, pointing out different areas and amenities. They went by labs full of tools that Jake couldn't even begin to name. He saw the Azurite physicists working with what looked like floating crystals that glowed from the inside through one window. Through another, Kelsorii mathematician priests sat in perfect circles with their eyes closed, thinking as one mind. As they walked, Talvos said, We have gathered the best experts from 12 species. All of the diagnostic tools that galactic science knows about are being used right now. We have looked at the system at the quantum level, the dimensional level, and every level in between. Jake saw that Talvos's scales changed color from blue to a darker shade. The alien was probably stressed out or even ashamed. It must have hurt the pride of these advanced civilizations to have to call in a human, someone from a species that was only a few light years away from their own solar system. They got to a conference room where Talvos had set up a presentation. The holographic display came to life, showing the huge communications array in 3 dimensions. Jake's translator overlay had a hard time keeping up with the data that was scrolling by in an alien script. Talvos said, "I have prepared a comprehensive briefing, using 2 hands to move the display and the other 2 to make expressive gestures. We have 14 terabytes of diagnostic data, analysis reports from every expert team, and complete system logs going back 2 years. I thought you might want to start by looking over the reports on the stability of quantum entanglement. They go into a lot of detail and should help you understand how complicated this situation is." Jake stared at the huge amount of information that was floating around in the holographic display. Charts, graphs, and math problems that would take him years to figure out. Sensor readings that didn't mean anything to him. He felt a knot in his stomach. What was he doing here? The technology these aliens had looked like magic. They had people who could process information faster than supercomputers. What could he possibly add? Then he thought of something his first boss had said to him when he was still learning the trade. Frank Martinez, an old man who had been fixing communications equipment since before Jake was born. Frank used to say, "If the computer can't tell you what's wrong, stop staring at the screen and go look at the real thing." Jake took a deep breath. "Talvos, I appreciate all this information, but I don't think I'll be able to understand most of it. Your technology is much better than anything we have on Earth. If I spend weeks trying to learn your systems from these reports, I'll just be trying to catch up with people who already know this stuff better than I ever will." Talvos's scales flickered with confusion. "Then what do you plan to do to help?" Jake said, "I'd like to see the real array. Not the information. Not the fake ones. The actual hardware. Can I go out there and see it?" Talvos was clearly surprised by the request. His 4 hands stopped moving. "Do you want to look at the relay stations in person?" "Yes." "Is that a problem?" "No, it's just that none of the other experts have asked for this. The diagnostic systems give a lot more information than just looking at something. The quantum scanners can find problems that are smaller than atoms. What could your eyes see that the sensors can't?" Jake shrugged, feeling a little stupid but sticking to what he thought. "To be honest, most likely nothing. But I'm not a physicist who studies quantum mechanics or a reality engineer. When communications equipment breaks, I fix it. And when something breaks at home, the first thing I do is check it out. Not on the computer screens. At the real thing." There was a moment of silence in the room. Jake could see that other aliens had gathered near the door to watch this conversation with interest. He heard bits of what they were saying in other languages. Some people thought it was funny. Some people didn't seem to understand what he was asking. One voice, sharp and dismissive, said something that his translator turned into primitive methodology. As Talvos thought about this strange request, his scales changed color several times. In the end, they settled on a light blue that was almost turquoise. "Very well. We can set up a tour of the inspection. It will take a few hours to see the main relay stations. I'll give you a maintenance pod and EVA gear that works with human bodies." "That would be great. And what about Talvos?" "I need my toolkit," I said. "Your tools?" Talvos looked at the metal case that Jake had brought with him. "Engineer Morrison, we have equipment fabrication facilities that can make any tool you need, and they can do it with tolerances that are much tighter than anything in that container." Jake smiled. "I know you do. But these are the tools I use. I know how they work. I have faith in them." An hour later, Jake was wearing an EVA suit that had been quickly changed to fit a human body. The maintenance pod was a small spacecraft, not much bigger than a car, that was made for doing close-up work around the array. The controls were easy to figure out, but Jake noticed that the alien designers had thought there would be 4 hands instead of 2. Jake could see the whole communications array for the first time as he flew away from Hub Station Prime and toward the nearest relay cluster. It was amazing. There were thousands of relay stations, each the size of a small building, set up in complicated geometric patterns around the spinning neutron star. Energy beams, which could be seen even in space, linked the stations in a glowing web. It looked like someone had made an artificial constellation, a structure that was only meant to be built and was very well built. He could hear the expert teams talking about his plan through his comm link. The Azurite scientist didn't seem too sure. "This is a waste of time. The simplest way to diagnose something is to look at it. But Kresh, the young council member who had suggested bringing Jake in the first place, stood up for the plan. Let him do it his way. We have tried everything else. Jake ignored the noise and paid attention to the relay stations in front of him. He took out his electromagnetic spectrum analyzer, which is something that most high school science labs on Earth would have. It was so easy compared to the strange tools the aliens were using. But it was something he got, something he knew how to read. He went from station to station, scanning, measuring, and writing down what he saw on his tablet. The work was methodical, almost like meditation. He didn't have a specific goal in mind. He was just looking and taking in what he saw, letting his past experiences guide his attention. Jake noticed something strange about Relay Cluster 7 4 hours into the inspection. Nothing big, nothing that made me think, there's a problem here. There was just a small problem with the housing of a few relay nodes. There are tiny scratch marks on a certain set of parts that are almost impossible to see. He marked the spot and kept looking around, comparing these nodes to others. The pattern kept happening. The relay node is always the same. The scoring on the housing is always the same. It wasn't a lot. It could have been nothing. But the computer diagnostics hadn't picked it up. And Jake had known for a long time that the smallest things could give him the biggest clues. Jake floated in the maintenance pod and looked through the reinforced viewing port at the relay node. The scratch marks were hard to see, they were just faint lines carved into the metal case. Most people would have completely missed them. He almost missed them himself though. But after looking at dozens of relay stations, it was clear what the pattern was. Only these nodes and not any others showed signs of scoring on the surface. He turned on his comm link. Talvos, are you there? The Velnari's voice came through right away. Yes, Engineer Morrison. Did you find something? Maybe. I'm looking at nodes 14 through 22 in Relay Cluster 7. There are some strange marks on the housings. It looked like something had scraped against the surface. Do you have any records of maintenance that I could look at? There was a break. In the background, Jake could hear muffled voices talking. It was probably Talvos talking to his team. When the chief engineer got back on the line, he sounded a little confused. Those marks would be tiny flaws on the surface. Our quantum sensors picked them up months ago but said they weren't important. The tolerances are well within the range of what is acceptable. These small changes in the surface can't change the states of quantum entanglement. Please humor me, Jake said. When did they put these nodes in? More talking in the background. Talvos then said, records show that those relay nodes were replaced 7 months ago as part of routine maintenance rotation. Does this matter? 7 months ago. Just before the problems began. Jake felt that familiar tingle in his stomach that told him he was onto something. It was the same feeling he had when he found the reversed valve on Outpost Kepler. It was the same instinct that had helped him a lot in his career. Can you get the maintenance schedule? Jake wanted to know. I want to know which other relay nodes were switched out at the same time. One moment. There was no sound on the line except for the soft hum of background systems. Jake took advantage of the time to move his pod to the next relay cluster and look at the nodes there. Sure enough, a few of them had the same faint scoring. He used his handheld scanner to carefully measure the depth and pattern of the marks and write them down. Talvos got back on the comm. I have the files. We changed about 40% of the array's relay nodes 6 to 8 months ago. It was part of a planned cycle of upgrades. The old nodes still worked, but they were getting close to the end of their useful lives. And let me guess, Jake said, already knowing what the answer was. Are the communication problems mostly happening in the places where these new nodes were put in? Quiet. Then Talvos's voice got sharper and more focused. How did you find out? Just a feeling. Please send me the replacement pattern with the failure map on top of it. Jake's tablet lit up with the data 30 seconds later. There was a strong link. Almost perfect but not quite. Areas with the new relay nodes had a lot more failures than areas with older equipment. It wasn't perfect. There was some noise in the data, but once you knew what to look for, the pattern was clear. This can't be right, Talvos said, and Jake could tell he didn't believe it. Those nodes were made to exact specifications. They passed the quality check. The diagnostic system said they were fully functional. Where were they made? Jake wanted to know. At our new automated facility on Velnari Prime. 3 years ago we stopped using the old factory. The new facility is much more efficient, making parts faster and at a lower cost. It uses cutting-edge molecular assembly methods that ensure accuracy down to the atom level. Jake smiled even though he didn't want to. He had heard that story before, but in different situations. A solar panel factory in Arizona had a similar problem back on Earth. A new automated assembly line, computer specs that were just right, and quality control systems that showed green across the board. The panels kept breaking down in the field, though. It turned out that the robots were putting in a part at an angle that was just a fraction of a degree off, but that was enough to cause problems after months of thermal cycling. The computers said everything was fine because they were looking at the wrong things. Jake said, "Talvos, I need you to do something for me. Get me one of these new relay nodes. A spare from the stock, not one that has already been put in. And find me one of the old relay nodes from before you changed manufacturers." "Can you do that?" "Yes, but I don't get what you want. In every way that can be measured, the new nodes are better. The molecular structure is more consistent. The quantum coupling efficiency is 0.03% higher. The amount of energy lost through the housing is lower by—" "Just trust me on this," Jake said softly. "Please." Another break. Jake could almost feel Talvos fighting against the request. The Velnari's training and experience told him that this was pointless. The new parts were better. It was clear from the data. But they were desperate, and desperation made them willing to do things they normally wouldn't. "Very well," Talvos finally said. "Go back to the station. I'll have both parts ready for you in Workshop Bay 3. Jake flew the maintenance pod back to Hub Station Prime, already thinking about what could happen. The scratches looked like they were caused by physical stress, like thermal expansion or vibration. Something was making the housings bend or move in ways that weren't planned. That tiny movement could mess up the fragile quantum states inside. When he got to the dock and walked to the workshop, there was already a small crowd there. People heard that the human was looking for certain parts, which made them think he might have found something. The Azurite physicist was there, and her body was made of crystals that reflected the lights above. A few Kelsorii had come, and their hive mind was interested in what was going on. One of the Physine engineers even came, but Jake still got a headache from looking at them for too long. Talvos was at a workbench with two relay nodes in front of him. One shone with the perfect finish of a brand new piece. The other one showed the slight fading and wear that comes from years of use in the harsh environment near a neutron star. Jake put down his tools and took out a simple micrometer, which is a tool for measuring thickness. The aliens watched with barely concealed doubt as he carefully measured the housing on both relay nodes. "What are you up to?" Harmony asked, her voice sounding like crystal chimes when it was translated. "Our sensors for manufacturing can measure down to the Planck length. That old thing is only accurate to a few micrometers at most, right?" "Micrometers matter sometimes," Jake said without looking up from his work. He measured different parts of each housing and wrote down the results on his tablet. The old relay node was about 3.2 millimeters thick all the way around. The new node was 3.197 millimeters long. 3 millimeters thinner. 3 micrometers. About 1/10 the width of a person's hair. Jake's heart raced as he stared at the numbers. Most of the time that tiny difference wouldn't matter. The part would still work perfectly in normal conditions. But these weren't normal circumstances. These relay nodes worked in one of the most dangerous places you could imagine. Right next to a neutron star that was spinning very quickly. Without protection, the radiation would kill a person in seconds. The temperature changes were very big. And those housings had to stay perfectly stable in size even under all that stress. 3 micrometers thinner meant that there was a little less material to absorb and spread heat. It meant that the structure was a little less rigid. That small difference could make the housings expand and contract just a little bit more than they were meant to in the harsh conditions near the neutron star. And that movement, sent to the sensitive quantum equipment inside, could break up entanglement states. Jake looked up at Talvos. "We need to try this." The workshop went completely silent. Jake held up his tablet so that Talvos and the other experts could see the measurements. 3.2 millimeters compared to 3.197 millimeters. The difference on the screen didn't seem like much. It was just a small change in the decimal. But the effects were huge. "This can't be done," Harmony said, her crystal body flashing with angry light. 3 micrometers of difference can't change quantum entanglement. The quantum processes happen on scales that are millions of times smaller. There is no physical way that such a large change could affect interactions between subatomic particles. Jake got why she was doubtful. He felt the same way the first time someone told him that a loose screw could shut down the whole power grid. But he knew that complicated systems often broke down in simple ways. Jake tried to keep his language simple when he said, "It's not about the quantum stuff directly. It's about the environment these things work in. You have a neutron star right there that is sending out a lot of heat and radiation. These housings need to be able to handle very big changes in temperature, right?" Talvos nodded slowly, his forearms crossed in a way that Jake had learned meant he was thinking hard. As they go around the neutron star, the relay nodes' temperatures change by almost 400 degrees. The housings are made to keep their size stable over that range. Yeah, designed to, Jake said. But if the housing is even a little bit thinner than it should be, it will expand and contract a little more than it should. The amount of thermal expansion is directly related to the amount of material. Less material means different expansion characteristics. He pulled up a simple physics diagram on his tablet, the kind that would be shown in a basic engineering class. Metal expands when it gets hot. It shrinks when it gets cold. Usually this isn't a problem because engineers plan for it. But if your house is bending even a little bit more than it should be, and it's doing this hundreds of times as it goes around that star, you're going to get microfractures. Points of stress. And those cause electromagnetic interference. One of the Kelsorii mathematician priests spoke up, and all of the bodies connected to it spoke at the same time. Our simulations took into account changes in temperature. We simulated atomic level changes in size caused by temperature. There were no patterns of interference. Did your simulations take into account flaws in the manufacturing process? Jake asked. Did you check what happens when the house is 3 micrometers too thin? The Kelsorii stopped talking. After a while, the prime mind said, we used design specifications to make it look like it was real. We thought that the parts we made would fit the plans. Jake nodded. That's what computers do. They are very good at figuring out what you want them to figure out. They won't find it though unless you tell them to look for it. Your quantum sensors were looking for strange problems because that was what they were made to do. They didn't check to see if the housings were a little too thin because that seemed too simple to matter. Talvos went to a terminal and looked up information about manufacturing. The new automated facility uses molecular assembly. It builds parts one atom at a time. The accuracy should be perfect. Should be, Jake said. But something went wrong. It's possible that the calibration was wrong. There may have been a mistake in the code. It's possible that someone made a mistake when rounding a number in the code. I have no idea. But the proof is right here. He tapped the relay node. These housings are too thin by 3 micrometers, which is why they break under stress. Jake's eyes still watered when he looked directly at the physine engineer, who moved closer to look at the relay nodes. It sounded like their voice was coming from all over the place. The person could be right. We have been looking for strange particle interactions, dimensional anomalies, and complicated ways that things can go wrong. We never thought about simple manufacturing variants because our quality control system said these parts were perfect. Perfect according to the sensors, Jake said. But those sensors were probably measuring quantum properties instead of basic physical dimensions. And if the same place that made the parts also calibrated the sensors, then both could have the same systematic mistake. Jake's cultural briefing said that the bright green color of Talvos's scales meant that he was excited or realized something. We need to test this idea right away. We can put one of the old-style relay nodes in an area with a lot of failures and keep an eye on how well it works. How long will that take? Jake wanted to know. To set up and collect statistically significant data? About 6 hours. There were more people in the workshop. Word of a possible breakthrough had gotten around the station. A dozen different kinds of scientists and engineers pushed against the door to see what was going on. Jake felt the pressure of their attention and tried not to think about what would happen if he was wrong. Talvos put together a group to do the installation. They chose Relay Cluster 7, which has one of the highest failure rates, and swapped out one of the new nodes for an old one they had in storage. Jake watched from a distance as maintenance drones carefully took out the broken part and put in the older one. It took about 40 minutes for the whole thing to happen. After that, there was waiting. Jake and Talvos were both in the observation room watching the data streams. Multiple displays showed communication signals that went through the test node. Each display showed the quality of the signal, the number of errors, and the quantum coherence measurements. The failure rate in that cluster stayed high for the first hour. Jake's confidence began to fade. He might have been wrong. It could be that the difference in thickness was just a fluke. He might have wasted everyone's time chasing a dead end. But then things changed. The error rate started to go down as the relay node made several orbits around the neutron star and went through several cycles of heating and cooling. At first things moved slowly, but then they sped up. After 3 hours, there were no problems with communications through that node. Not just low errors but perfect transmission. People in the observation room started talking excitedly. Talvos's scales shone with a rainbow of colors. "It's working," he said, his voice full of shock. "That one node is working perfectly, but the other nodes keep failing." Jake let out a breath he didn't know he was holding. "We found it. The new relay housings are too thin. The heat stress close to the neutron star makes them form tiny cracks. Those cracks cause electromagnetic interference, which messes up the quantum entanglement. As Harmony got closer, her crystal-like body glowed with a softer, almost embarrassed light. You were right. We missed this with our advanced sensors, quantum analysis, and dimensional scans because we were looking at the wrong scale. We were looking for strange reasons when the answer was just quality control in manufacturing. The Kelsorii Prime Mind said, our simulations were perfect, but only for the system we designed. We didn't think about the fact that the system we made might not have followed the design. A mistake made because we were too sure of our production methods. Jake looked at the data from the relay node that was still coming in on the screens. Spent 47 million credits. The smartest people in the galaxy worked for 6 months. All to find a problem that was caused by a 3-micrometer manufacturing flaw that any quality control inspector with a micrometer could have found. Jake said, don't beat yourselves up. That happens all the time on Earth too. We forget to check the basics because we get so caught up in the complicated explanations. I know of million-dollar server farms that went down because someone forgot to plug something in. Having advanced technology doesn't mean you can't make simple mistakes. It makes you more likely to fall for them because you stop looking for them. Talvos put one of his hands on Jake's shoulder. You found what we couldn't find in 6 months and 47 minutes. How? Jake shrugged. I didn't know enough to think it couldn't be something easy. The test results spread like wildfire through Hub Station Prime. In less than an hour, all of the station's expert teams had met in the main conference hall. There were beings from a dozen different species in the room, and they were all staring at the data displays that showed how well the test node was working. The noise level was off the charts. There were translated voices arguing, asking questions, and trying to figure out what they were seeing. Jake stood near the front with Talvos, feeling very out of place. He was wearing his usual work clothes, still had grease under his nails from working with the relay nodes, and was in the company of the smartest people in the galaxy. Some of them had been studying physics for longer than people had been using fire. Harmony was the first to speak up against it. Jake's translator helpfully pointed out that her body had turned a deep red color, which meant that she strongly disagreed. This can't be the reason. The math doesn't back it up. A 3-micrometer difference in housing thickness is not enough to cause enough electromagnetic interference to break quantum entanglement. The levels of energy are wrong. The frequencies are incorrect. This mechanism just doesn't work with physics. She pulled up a complicated holographic equation that took up half the room. Jake didn't get most of it, but he knew it was a math proof of why his theory shouldn't work. I've done the math 17 different ways, Harmony said. In every case, the interference caused by a housing that is 3 micrometers too thin is at least 6 orders of magnitude too weak to change the quantum states. The entangled particles shouldn't be able to hear or see any of this rough electromagnetic noise. A Kelsorii mathematician stood up, and all of its connected bodies rose at the same time. We agree with the Azurite analysis. We have looked at this from every possible math point of view. The suggested mechanism goes against well-known rules of quantum shielding. These relay nodes were made to work in places with a lot of radiation. They have several layers of protection against interference from electromagnetic waves. Jake's stomach started to feel like it was tied up. He wasn't a physicist who studied quantum mechanics. He couldn't argue with their math. He might have been wrong after all. The test result could have just been a coincidence, a random change that happened to fit with his theory. But then one of the Draxian structural engineers spoke up. Have any of you really tried out the shielding on these new homes? Or do you think it works as planned? The question was still in the air. The crystal shape of Harmony flickered. The housing's molecular structure includes the shielding. It should be a part of the material itself. The Draxian said again, should be. But if the housing is thinner than what was said, the shielding is also lessened by the same amount. 3 micrometers may not seem like a lot, but if those 3 micrometers include 2 micrometers of shielding material, you've just lost 2/3 of your protection. Talvos looked up the technical details for the relay housings. His 4 hands quickly moved over several control panels at once. The specs show a design with many layers. The outside 1.4 millimeters is the structure's housing. The quantum shielding matrix is inside the 1.8 millimeters. If the total thickness is cut down by 3 micrometers, then the shielding layer is taking most of the loss, Jake said. Because the automated facility probably put more emphasis on keeping the outer structural layer intact and compressed the inner layers to make up for it. Harmony's color changed to orange, which meant she wasn't sure. That would explain how it works, but it still seems unlikely. Our quality control systems should have found that the shielding wasn't good enough. How do your quality control systems check the shielding? Jake asked. They check the quantum isolation coefficient. They simulate interference on the parts and check that the internal quantum states stay stable. Simulated interference? Jake said again. How strong? Harmony asked a data panel for help. Standard testing rules. The same levels we've used for 300 years. Jake got that familiar tingle again, the feeling that he was onto something. Are those standard levels based on the normal background radiation that is close to a neutron star? Or do they take into account the thermal cycling, the expansion and contraction, and the microfractures that form over time? The room got quiet. Jake could see that people, both strange and familiar, were starting to get it. The quality control tests were static and done on new parts in a controlled setting. They didn't think about what would happen after hundreds of thermal cycles, when the housings had expanded and contracted thousands of times and microfractures had built up in the material. There were voices coming from all over the place that sounded like a physine engineer. The person is right. We test parts when they are new, not when they are worn out. If a housing passes initial testing, it could fail after weeks of thermal stress, especially if it started with less shielding thickness. One of the Kelsorii said, "This is embarrassing, breaking the hive mind's normal pattern of speech." Some of its bodies looked like they were really in pain. Talvos raised his hands to get attention. It doesn't matter if we're embarrassed or not. The important thing is that we might have found the problem. I think we should do a full test. We will take out an entire relay cluster and replace it with nodes that are no longer up to date. We will then watch it for 24 hours. We will know for sure when the failure rate in that cluster goes down to 0. And what if it doesn't? Harmony is in trouble. Then Engineer Morrison was wrong and we keep looking, Talvos said simply. But we've spent 6 months and 47 million credits and haven't seen any results. I think we can spare another 24 hours to test a theory that has already shown some promise. There was a lot of disagreement about the vote. About half of the experts voted for the test because they thought the evidence was strong. The other half voted against it, saying that the theory was physically impossible even though the first test results showed otherwise. Talvos finally used his power as chief engineer to order the test anyway. Jake spent the next few hours watching as maintenance teams methodically swapped out all of the new relay nodes in Cluster 7 with old ones from storage. There were a total of 36 nodes. It took about 20 minutes to replace each one. The work was organized and careful, and Jake drank cup after cup of coffee from his thermos because he was so nervous. Kresh, the young council member who had suggested bringing Jake to the station, found him in the lounge for observation. "How are you doing?" "To be honest," Jake said, "I'm scared. Another day wasted and things got worse if I'm wrong about this." "You found something that none of us thought to look for," Kresh said. "That's already useful, even if it was just a coincidence." "But what if it is just a coincidence? What if the first node just happened to start working as soon as we put it in?" Jake had learned to read Kresh's face during their briefings, and it looked like he was amused. "Then you'll have failed just like the rest of us have for the past 6 months. But I don't think you're right. I've studied people long enough to know how you solve problems. You don't let complicated things get in the way. You look for the simplest explanation that fits the facts. The work to replace it took 8 hours. Then there was more waiting. Jake couldn't sleep though. He kept an eye on the data feeds and the communication quality metrics for Cluster 7. Nothing happened for the first few hours. The rates of mistakes stayed high. But then, little by little, the numbers started to change. At first, one node got better, then another, and then several at once. Cluster 7 was working at 98% efficiency after 20 hours. At hour 24 it reached 100%. No mistakes. Communications that are perfect. Using older parts that fit the original design specs brought an entire cluster back to life. The conference hall filled up again, but this time the mood was different. There was no more arguing or debating about whether the theory could work. There was no doubt about the data. The old relay nodes worked. The new ones didn't work. The difference was 3 micrometers of missing material, and those 3 micrometers had brought the whole galaxy to its knees. Harmony walked over to Jake, her crystal-like body now a soft blue. "I was wrong. I did the math right, but my assumptions were wrong. I'm sorry I doubted you." Jake said, "You don't have to say sorry. Your math was correct. If the housings were built to spec, they shouldn't have failed the way they did. They failed because they weren't built to the right specifications and no one thought to check that." The Kelsorii Prime Mind spoke and all of its bodies moved in perfect harmony once more. "We learned something important today. Being sophisticated doesn't mean you're wise. We got so good that we forgot the basics." Jake looked around at all the experts who had come together. These were beings whose civilizations had mastered technologies that humans couldn't even think of yet. But they all missed something simple because they were looking for something complicated. Everyone goes through it, Jake said with a small smile. Sometimes you just need a new point of view. The real work began once the problem was found. Talvos called an emergency meeting to come up with a plan for fixing the whole communication system. The main conference hall was full again, but this time everyone was talking about how to solve problems instead of arguing about theories. Jake sat at the planning table, still feeling like the whole thing was a dream. He had been fixing antennas in Denver a week ago. Now he was in charge of fixing a communications network that spanned the whole galaxy. Talvos said, "We have about 12,000 relay nodes currently installed across the array." He moved the holographic display around to show the full extent of the problem. Based on records from the factory, about 4,800 of those are new specification units that have the thickness problem. You need to replace those right away. A logistics coordinator from the Meridian species, who had 6 legs and compound eyes that made it look a little like an insect, pulled up supply data. We have about 3,000 old-style relay nodes stored in different station storage facilities. They were kept as backups in case of an emergency. That means we are short 1,800 units. Someone asked, "Can we make new ones that meet the right specifications?" Talvos's scales flickered with anger. The old factory on Velnari Prime was shut down 3 years ago. They sold the equipment for scrap. It would take months to get production back up and running, and we don't have that much time. The failure rate is now 32% and rising. We'll have a total network failure if we don't act quickly. Jake had been thinking about this issue while looking at the test results. What about the new automated building? Can you change the programming so that the housings are the right thickness? Talvos said, "In theory, yes. But it's not easy to recalibrate molecular assembly systems. It might take weeks to make sure the new specs are right. We would have to do a lot of testing to make sure we don't make things worse." The Meridian coordinator said, "We don't have weeks. At this rate of degradation, we'll lose another 15 systems in 10 days. People in the room started to worry and talk. Several teams began to suggest solutions, each one more complicated than the last. Someone suggested using different technology to build temporary relay stations. Another group suggested sending communications through extra paths, but that would cut down on the network's capacity by a lot. The physine engineer even suggested trying dimensional folding to completely avoid damaged nodes, even though they knew the technology was still in the testing stage and could be dangerous. Jake listened to all of these ideas and got more and more worried. Instead of just fixing the problem, everyone was trying to come up with complicated ways to work around it. It made him think of a time on Earth when a satellite network didn't work right. Engineers had been working for weeks on complicated software patches to get around broken hardware. It would have been faster and cheaper to just send up a maintenance crew to fix the broken parts. Why are we making this so hard? Jake finally spoke up, breaking up a heated argument about quantum bypass protocols. The room got quiet. Talvos looked at him. "What do you mean? Do you have 3,000 good relay nodes in storage? And you know exactly which nodes are bad. So go ahead and start replacing them. Use the 3,000 you have to fix the places that fail the most often first. That will make the network more stable right away and give you time to make more replacements. But we'll still be 1,800 units short," the Meridian coordinator said. "Okay, so while you replace the parts, you also recalibrate the automated facility," Jake said. "On the first try, it doesn't have to be perfect. Make some test units, use simple tools to measure them and make sure the thickness is right, and then start making them. You can make things and put them together at the same time. You use the new units to replace the bad nodes that are still there." Harmony, who had been quiet since she admitted her mistake earlier, spoke up. "That way of doing things isn't very elegant. We would have to use a system that wasn't fully working for weeks. But a system that is only partially compromised is better than one that has completely failed," Jake said. "Right now you're failing 32% of the time. You could probably get that down to 15 or 20% in a week if you replace the nodes in the worst areas first. It's not perfect, but it works. Then you keep making it better as more replacement parts come out." Talvos's scales changed to a deep green color. A phased approach to repairs. First, deal with the most important areas, and then go through the rest in a planned way as resources allow. Exactly. It works even though it's not fancy. The Kelsorii Prime Mind thought about this. The human strategy puts short-term, partial improvements ahead of long-term, perfect solutions. This goes against the way we usually do things, which is to plan everything out before we start. Sometimes you can't wait for the right plan, Jake said. Sometimes you just have to get to work on fixing things. The council agreed to use Jake's phased approach. Within 6 hours, maintenance teams were sent out to all parts of the array. We sent the 3,000 old specification relay nodes to stations near the areas where failures happened most often. Crews worked in shifts around the clock to carefully replace broken units. Jake pushed for one more step that people didn't want to do at first. Measure each replacement node before you put it in. Use a simple micrometer. It only takes 30 seconds per unit. Check to see if the housing is really 3.2 millimeters thick. I know the old nodes should be fine, but since this whole thing started because everyone thought the new nodes were fine, maybe we should really check. Talvos agreed right away, and the installation protocol was updated to include the verification step. This, interestingly, caught 3 old nodes that had been mislabeled and were actually new specification units. Those would have been installed and kept breaking things if the manual check hadn't been done. At the same time, a group of Velnari engineers came to the automated manufacturing plant. Jake took part through a video link and gave suggestions based on his experience with manufacturing systems on Earth. It turned out that the recalibration was easier than we thought. There was only one error in the facility's programming, a rounding function that had cut off the housing thickness specification. Someone programmed it to round to 2 decimal places instead of 3. This changed 3.200 to 3.20, which the system thought was 3.2 millimeters but actually made 3.197 because of how the molecular assembly figured out how to deposit material. A single line of code. That was the cause of the whole problem. One small mistake in rounding that didn't seem like a big deal during programming but caused problems later on. 5 days after Jake's discovery, the first batch of fixed relay nodes came off the production line. Before being sent out, each one was measured and checked by hand. The measurements were perfectly consistent at 3.2 millimeters. This time, quality control included both advanced quantum testing and Jake's insistence on simple physical measurement. In less than 2 weeks, all 4,800 broken relay nodes had been replaced. The rate of communication failures went down from 32% to 0.003%, which was actually better than the network's performance before the crisis started. The last few failures were caused by unrelated age-related degradation in nodes that hadn't been replaced in decades. The repair cost just under 80,000 galactic credits. Most of that money went to pay for the work of the installation crews. The replacement parts didn't cost much because they were already in storage or made from materials that were already available. It cost $47 million to figure out what was wrong, and $80,000 to fix it. Everyone involved knew how big the ratio was. At a dinner in Jake's honor, Talvos raised a glass of something that bubbled and glowed softly. To Engineer Morrison, who taught us that the simplest answer is sometimes the right one. Jake held up his own glass, which was full of water because he didn't want to try alien alcohol. To check your work with a micrometer before you think the computer is right. The guests who had come together laughed, but Jake thought that many of them were still embarrassed about the whole thing. He didn't hold them responsible. If the roles were switched, he would probably feel the same way. The most important thing was that the network was working again. 847 star systems were once again able to talk to each other. Trade routes were open again. Families had gotten back together. Civilization had pulled back from the edge of disaster. All because someone remembered to check the basics. 3 months after the communications array was fully restored, Jake was back on Hub Station Prime for what the Galactic Council called a special session. He was happy to be back on Earth after the repairs were done. He was glad to be back to his normal life and out of the spotlight. The Council, on the other hand, had told him he had to come back for this meeting because it was important. They wouldn't tell him what it was about, which made him feel uneasy. The Council chamber was even more crowded than usual. There were people from what seemed like every major civilization in the galaxy sitting in the seats. Jake saw Talvos near the front, and his scales were a calm blue-green. There was also Harmony, whose crystal body caught the light. It looked like the Kelsoria had sent their whole Prime Mind group. Even the Sci-Fi had a lot of people there, but looking at them still made Jake's head hurt. The session was called to order by Council Speaker Vrenta. Her old voice could be heard clearly all the way across the big room. We're here today to talk about what we've learned from the recent communications crisis. The immediate issue has been fixed, but we can't ignore the bigger questions about how it happened and how it was fixed. She pointed to a holographic screen that showed numbers from the crisis. The timeline of failures, the millions spent on tests, the teams of experts who found nothing, and finally Jake's 47-minute investigation that found the real problem. For 6 months, we used our best technology to try to solve this problem, Vrenta said. We used quantum scanners that could measure things at the Planck scale. We used dimensional analysis to look at things that were outside of normal space. We did simulations that used more processing power than whole star systems can handle. And we didn't find anything. She stopped for a moment to let that sink in. Then, in less than an hour, a human engineer with a micrometer, a tool that is so simple it predates faster than light travel by hundreds of years, found the answer. We should be very worried about this. Whispers spread through the room. Jake moved around in his seat, which made him uncomfortable. He didn't like being used as an example. He had only done his job the way he had been taught. Talvos stood up to speak to the council. The crisis showed us a major flaw in our engineering culture. We depend so much on advanced diagnostic systems that we've forgotten how important it is to see things for ourselves and check them out. We can no longer trust our senses or simple tools because our technology has come so far. We think that if our quantum scanners don't find a problem, there isn't one. A person from one of the academic world stood up. Are you saying we should give up our advanced diagnostic tools? Not at all, Talvos said. I'm suggesting we add what people call ground-up verification to them. Basic physical checks should go along with advanced diagnostics. Quantum analysis should be done along with manual measurement. Computer simulations should be checked against real hardware inspections. Harmony stood up, and her clear body pulsed with what Jake had learned to recognize as strong conviction. I have spent the last 3 months going over the event in great detail. My first analysis was mathematically correct, but it was useless in real life because it was based on wrong assumptions. I thought the manufactured parts met their specifications because our quality control system said they did. I never thought that the quality control systems themselves might not work right. She looked right at Jake. The way people do things is very different. People don't assume anything. They check everything. It's not because they aren't as smart as we are. They've learned to be skeptical because their technology doesn't work very often. They've kept a culture of fixing things by hand that most of us lost thousands of years ago. Next, the Kelsorii Prime Mind spoke, and all of its bodies moved in time with each other. We want to make big changes to the way galactic engineering is taught. What we're calling human-style diagnostics should be a part of every technical curriculum. Students should learn how to use both basic and advanced tools. They should learn how to check hardware by hand, question computer readouts, and check their own assumptions. This started a fight right away. Some representatives thought it was a great idea. Others thought it was rude, like they were being told to go back to old ways of doing things. The argument went on for almost an hour. At last, Vrenta raised her hand to get everyone to be quiet. Can I ask Engineer Morrison a question? Jake, why do you think your way worked when ours didn't? Jake stood up slowly, knowing that hundreds of people were watching him. I don't believe I'm smarter than anyone else here. I know for sure that I am not more educated. You all know more about physics than I'll ever learn. But I had one thing going for me. I didn't know enough to think that the problem had to be hard. He stopped for a moment to think. We have a saying on Earth. If you hear hoofbeats, think horses, not zebras. It means that the most obvious answer is usually the right one. You all heard hoofbeats and began searching for strange alien beings because that's what you had learned to expect. I heard hoofbeats and looked for horses because I didn't know what else to think of. But it's more than that, Jake said. It's about keeping in touch with the physical reality of what you're doing. For the past 15 years, I've been fixing communication devices. I don't just look at diagnostics when something breaks. I go see the thing that is broken. I touch it, look at it, and use basic tools to measure it. That's not because I'm old-fashioned. It's because computers sometimes lie, sensors sometimes fail, and diagnostic systems sometimes miss things. To be sure, you have to look for yourself. A young delegate from a species Jake didn't know stood up. But as civilizations grow, we should surely move past these manual methods? Isn't that what progress is all about? Getting better shouldn't mean forgetting the basics, Jake said. You should use all the advanced technology you can get your hands on. But don't let it take the place of common sense and direct observation. Yes, use your quantum scanners. But you should also use a micrometer now and then. Do your computer simulations but also check out the real hardware. Trust your diagnostic systems but double-check what they say. Talvos also said, we have reopened the old factory on Velnari Prime. Not because the automated facility isn't good but because we need backups. We need people who know how to make things by hand and understand the physical processes that go into automation. The old building is now a training center where young engineers learn both traditional manufacturing and modern molecular assembly. The council worked on what they called the ground-up protocol for the next few hours. It was a complete overhaul of the standards for galactic engineering. Now, every big project would need to be checked in more than one way. Basic physical inspection would be done along with advanced diagnostics. Quality control would use both advanced sensors and simple measurements done by hand. At least one person on each engineering team would need to know how to use primitive troubleshooting methods. The Velnari Technical Institute said it was starting a new department that would focus on basic engineering skills. Other colleges and universities quickly followed. In just a few weeks, courses on human-style diagnostics were available all over the galaxy. The course covered how to use basic tools, how to check things by hand, and how to be skeptical of automated systems. Jake was asked to join the newly formed Galactic Engineering Council, which was set up to make sure that the new protocols were followed. He would be working on projects that people wouldn't be able to do for hundreds of years, and the pay was great. But after thinking about it for a few days he said no. Why? Talvos asked what Jake had told him. You could change the course of galactic engineering. Someone has to keep doing the work, Jake said with a smile. You need people in the council chambers to make decisions, that's for sure. But you also need people out there with toolkits and micrometers who are willing to get their hands dirty and keep things going. That's where I can help. That's where I feel good. Jake did accept one honor before he left Hub Station Prime for the last time. The council set a new unit of measurement in the technical standards for the galaxy. The Morrison tolerance was set at 3 micrometers, which was the smallest difference that could cause a system to fail completely. It was a reminder that small things were important and that perfection in theory didn't mean anything if the product didn't meet specifications. Jake went back to work at the Deep Space Monitoring Station on Earth. His boss had kept him in his job, but she said she had thought about promoting him to management after he became famous in the galaxy. Jake was happy when she changed her mind. You should be up there on those towers, not behind a desk, she said. Jake couldn't agree more. He was back to his normal routine in less than a week. Checking the alignment of antennas, replacing broken parts, and running tests on his old beat-up equipment that worked just fine, thank you very much. He was working on a relay that was having problems on and off one afternoon. The computer tests kept saying that everything was fine. There was no pattern in the error logs. Most engineers would have spent days looking at the data, running simulations, and maybe even giving up and replacing the whole unit. Jake got his tools, climbed the tower, and found a loose bolt in about 15 minutes. He tightened it, climbed back down, and the relay worked like a charm. As he put away his tools, he thought that sometimes the answer really was just a loose bolt. And no amount of high-tech tools could make up for the value of actually going out and looking. A message from Kresh came through on his phone. During the crisis, the young council member had become a friend. The message said that the first group of students had finished the new human-style diagnostics courses. They were already making a difference by finding problems that would have gone unnoticed before. Jake smiled and sent a thumbs-up emoji back. Then he looked up at the antenna tower he had just fixed, the sky above the Earth and the stars beyond, where an entire galaxy was learning that sometimes the simplest way was the best way. Check the basics first, he said to himself. This was a phrase that had worked for him for 15 years and had apparently been worth $47 million.